Hello everyone, welcome back to Data Speaks and welcome to the last part of this bank marketing dataset binary classification machine learning project. Here in this last part, we are going to compare all the models that we have trained so far, including fine-tuned or hyperparameter tuned random forest model. We'll say all models and pd.data frame. Then we will have logistic regression models, decision tree model result, random forest, and tuned or hyperparameter tuned random forest. And then we'll have that all sorted by test ROC-AUC score. That's what matters the most at this point to us. Let's run that code. Here we have got highest test ROC-AUC score, which is 93.03. That's the highest for tuned random forest model. Then rest others are 92, 90, even 87 for the decision tree. So based on that, and if you see rest others too, training accuracy, tuned random forest has the highest. Even the test accuracy, tuned random forest has highest. Test precision, basically it also has highest. Test recall, it doesn't have the highest. Well, it has just opposite, lowest. Test F1 score, which happens to be second highest at this point. And now we have the result here. So we found that tuned random forest has the highest overall performance out of all four models trained. We have not done the hyperparameter tuning for the rest of those three models. If you want to try that out, try it out and let me know in the comments. What do you find with the hyperparameter tuned logistic regression decision tree? Based on that, what we are going to do is final prediction on the test data, utilizing best performing model, which is best random forest model. Call final test predictions, call the best model, which is best RF model, the random forest model, and we want to predict the class label 0 or 1 on the X test data. X test is the data set which we are going to feed. We have the Y test, but we do not want to show that yet to the model. We will use that to evaluate the performance. Then we have a final test probabilities. We want to check what is the probabilities for the predicted class being 1. Then we want to have the data frame, structured data frame for those results. Then we want to create the copy of the X test dataset so that we can add the actual and predicted labels and also the probabilities on the X test so that we can compare the results. So here we will call test prediction results. We'll begin with the X test set, creating the copy of it. Then we will add a column actual Y, which is the actual labels that we already have, but the model has not seen them. So that is the Y test dot values. Then we will add a new column called predicted Y on the same data set, and we will call final test prediction, which we have created over here using the best random forest model. Then predicted probabilities, which we have already computed over here to identify what is the probability of model predicting label 1, and that's going to be the another column into that test predicted results. Then we will finally show the top 5 results of the test prediction results. So let's run that code, and here we have got those top 5 rows of that, and here all the way to the right we have actual labels, predicted labels, and what is the probability of predicting label yes or label 1. Since the prediction is 0, of course we expect the probability to be very low for the class 1 or label 1 or label yes. So that is much more expected. So looks like our model is doing good job there. We want to also check what are the most important features that random forest, the best random forest model, utilized to come up with that performance level. So what we want to do is we want to call the preprocessor step to have the cleaned up dataset. Then we want to call the numerical and categorical features. We want to perform the necessary data preprocessing on them. And we want to concatenate all the features, all the columns that we have in the dataset. Then we want to call the feature importance function on the best performing random forest model. So random forest model and decision tree model, a lot of time not only are used for as a machine learning models, but also for the feature importance. Likewise, other models including logistic regression, linear regressions, these models can also be used as a feature importance or to get the best features using their coefficient values. Now, once we have those feature importance function applied, then we want to organize that into the structured data frame. And then here we want to call features and the importance value. Then we want to sort that values by the importance. Then here we want to call top 20 features if we do have that. Let's run that code and let's see what result we are getting out of it. So here, duration, age, then we have a balance, then we have a day. These values are in the ratio, or you can convert that with the percentage by simply multiplying them by 100, which is going to be 36.65%, here 6%, 6.31%, here we have 6.25%, here we have 5%, and so on. In the descending order, we'll have, as we go down, we'll have a lesser and lesser important features, but looks like we have got our top 5 features over here at the very top, including duration, age, balance, day, and P outcome access. So these are the most important features for the random forest model. We can see the same information by plotting into the visual graph. That will give you a really nice picture of that visualization that tells us duration is the most important feature that have extremely high importance, where rest of the features, these are the least important features as we go down into the descending order. Once we understand that we have the best features and also understanding of what model is the most important, then the next step we are going to do is save the model locally so that we can use that model to deploy, if you want to deploy, into the web application or in company's portal if it was actually the production grade application. So to do that, we are going to call, first of all, we are going to make a directory or folder into the your working directory. Then we are going to save the trained model. We are calling that bank marketing binary classifier.pickle, the pickle file. On that name we have given. So we are going to dump our model, best random forest model, into the path that we have defined over here. So whenever we want to call the model, we have to call this bank marketing binary classifier.pkl, that stands for pickle file, which is the saved artifact of the trained model. Now our model is saved locally. So here in my directory, you can see that the model have been already saved as a binary classifier pickle file. Now, once we have saved that locally, you can download the model or export by attaching to the email, uploading to the data dump you have into the SharePoint locations, or whatever. If you're using Amazon Web Services Cloud, you can upload that into the S3 bucket. However you want to share, it's really shareable trained model by now. We have completed the training and exporting the model externally after model has been trained and validated. So how about we quickly load the model and then predict for any one random feature, random data set that we have in our data. So to do that, you have to say loaded model. We can give any name you want. Then from the job-lib library, you have to call the load function and give the model path, whatever you have stored. Or you can give complete name of the model if you like to do so, whatever name you have saved with. Then have a data set that you want to build a prediction. For example, I want to pick a very first row. You can pick any row you like to. So we'll change that in a second and see if that is going to do a good job or not. Then we are asking the model to predict the label for that specific record. Then we want to also have the predicted probability. So what is the probability of labels, the class being label 1, the predicted class being label 1. Then we want to have the prediction and the probability both printed for that specific record. Let's run that. So in our data set, as we have seen here, in the data that we have age 40, blue collar job, and marital status married, primary education, and default, loan default, no, all of those situations, 640 balance, etc., that customer has the prediction being 0. So basically, customer is likely not to subscribe for the term deposit. And the probability of subscribing for the term deposit is only 0.5%, which is extremely small number. How about picking up different row? Here, I will change the row position and see if I'm getting anything different. Let's say 43rd record in our data set, and that we have something different result. Also, the predicted class label is 0, and the probability of class being 1 is just 0.58% as well. And customer is a blue collar job holder, and age is 49, married, primary education, etc. Balance is 1387, and housing owns the house, etc. And having this customer is likely not having to subscribe for the term deposit. So this is how you can use any data set to build the predictions. So this was a final test that we wanted to do into our entire big large series of binary classification machine learning. With that testing and all of those activity that we have done, we have concluded this series of the binary classification machine learning model in the bank marketing dataset. I hope you enjoyed if you had followed the entire series. If you have not, please go ahead and subscribe, and then also check all the videos from part 1 until the part 9. I hope that's going to be very helpful for you to build a strong understanding of how binary classification end-to-end machine learning model development process works, and I hope that's going to be helpful for you in the future if you are working on this similar kind of projects or any diverse project using binary classification type of use case. So final summary here of this entire tutorial series: we have loaded the data set, we have explored the data, checked missing values and unknown values, duplicate checking, then we have performed the numerical and categorical data, exploratory data analysis, we have visualized the data, checked for outliers, we have performed feature engineering, then we have build the pre-processing pipeline, then we have trained 3 different models including logistic regression, decision tree, and random forest. Then we have done the model evaluation technique using different classification model evaluation technique. Then we have fine-tuned random forest using grid search CV. Then we have generated the final test prediction. Then we have done the fine-tuning using grid search CV. And then we have also generated the final prediction, then saved model locally, and also we have tested the model's performance on individual couple of records. So I hope you enjoyed this entire series, and thank you for watching this video until the last. If you have not already subscribed to my YouTube channel Data Speaks, please do subscribe and hit that like button on this video, plus also other videos that you watch. And if you have any specific curiosity or you want to learn about some specific topic, please let me know in the comments of this video or any other video. I will definitely try to make that video as soon as I can. And thank you for that comment in advance. And I will see you in the next videos. Until then, please enjoy learning.